Okay, guys, very quickly, I'm going to look at something beautiful. And of course, I want to specially welcome you to this class. We're going to start the first 10 classes under your Jamb 400 chemistry series. Of course, we have a total of 400 questions here, and we're going to take it 10, 10, 10 all through. Are you ready? This is our part 1. And these all questions are questions that Jamb don't play with. These are the areas that Jamb keep revolving around year in, year out. You can't tell me that you have dedicatedly run through the whole of these 400 questions and you now go and miss any question in the whole. It's not possible. It's just dependent on your seriousness. Don't cram, please. One of the big problem with students is cramming. Sir, I can't. No, don't cram anything. Not that you look at the question and say option number 1 is option A. No. The most important thing is you understanding it to the core. So roll with me as we flow together and look at all of it from the beginning to the end. You must know the reason behind everything. That's how you are going to succeed. Let's go. Look at question 1 very quickly. The question says, which of the following is used in the manufacture of glass? In other words, this question is coming directly from glass, the manufacture of glass. Option A, we're giving your sodium chloride. Is it sodium chloride that we use in the manufacture of glass, or it is your sodium triazocarbonate 4, or we make use of your sodium tetraoxosulfate 6, or what we make use of is your sodium triazonitrate 5. What is it that is used in the manufacture of glass? Very simple. This one is cheap question that they keep revolving around. The answer is option 1 B. What is B? Sodium trioxocarbonate 4. What is your B? Sodium what? Trioxo what? Carbonate 4. Are you getting me now? So, under your carbonates, especially when you're dealing with the carbonate of your sodium, that's your triazocarbonate 4, right? Beautiful. That's what we use in the production of your what? Glass. It's one of the constituent raw materials. Let me explain. What are the uses of your sodium carbonate? The one you call your sodium triazocarbonate 4. What do we use it for? Number 1, it is used in softening hard water. So, if you have hard water, what is one of the major things that you can use to soften it? It is your sodium trioxocarbonate 4. Another use is that it's used in making your what? Your soap. So, we use your Na2CO3 in the production of your soap. Don't forget this, that it is also a primary standard in acid-base titration. So, you want to carry out your volumetric analysis, all this your titration, practical, and all of that. Of course, Na2CO3 is what? A primary standard in acid-base titration. Don't forget number 4. It is used, right, mildly as what? An alkaline. Hold on. Because it is an alkaline, is it a strong alkaline or it is just mild? It is mild. Hence, right, the aqueous solution of it is used in treating concentrated acid splash. So if concentrated acid splash on somebody's skin, what can you use to calm the effect down? You need your what? Your sodium carbonate, the one you call your sodium trioxocarbonate what? 4. Are you with me? This one is a constant question. They have had this question as well. Number 5, it is used in the manufacture of what? Glass. This is where they picked it from. Your Na2CO3 is used in the manufacture of what? Glass. How do we know? Let's look at glass a bit. First, you must understand this, that glass is a super cooled liquid. And of course, it is a mixture of your trioxosilicate phosphate of your sodium and your what? Your calcium. But here is the important thing I want you to hold tight. And don't forget this very quickly, that in the manufacturing of glass, very important. How many things do we need? Just 3 of them. So those 3 things, you must heat them together. So glass is made by heating a mixture. The 3 things are exam questions. Number 1, your silicon 4 oxide, the one you call your sand, or you call it your silicate, right? Or we call it your silica. What is it? SiO2. SiO2 is needed. That's your what? Your silicon 4 oxide. You need it in the production of sand. You must know the 3 things. Number 2, you need your what? Your anhydrous sodium triazocarbonate 4. What is your anhydrous sodium triazocarbonate 4 there? Na2CO3, the one you call your what? Your soda ash. What is it? Na2CO3. So this guy, you use it in the production of your what? Your glass. Na2CO3. That's your sodium triazocarbonate what? 4. Another very quickly is your calcium triazocarbonate 4. which is your CaCO3. So give me the three things that you need in the production of glass. Number one is your what? Your silica, or the one you call your silicate, SiO2, plus your Na2CO3, the one we call your what? Your soda ash, or you call it your what? Your sodium triisocarbonate 4, but the anhydrous format of it, plus what do you need? Your calcium triisocarbonate 4, CaCO3, the one you call your what? Your limestone, or your marble, or your chalk, or your aragonite, or your eggshell. That's the formula, CaCO3. So you need these three major things in the production of your what? Your glass. One to go. What are the three things? SiO2, Na2CO3, and your what? Your CaCO3. Very simple, easy, and what? Direct. Does it make sense? Don't forget that you need the what? The carbonates of your sodium and your what? Your calcium, in addition to your what? Your silica, in the production of your what? Your glass. You get that very quickly. That's all very simple, easy, and direct. Don't forget this, that mixture of those three things, right? You need to heat it in a furnace. When you heat it in a furnace, what will happen? It will form a molten substance, right? And when you cool it, what is it going to form? It's going to form your what? Your soft glass. What will it form? Soft glass. Your soft glass, also called your what? Your soda glass. Now, don't forget, what is the reaction that is involved there or needed? They're very simple. All you need is your Na2CO3, right? Come and heat it with your what? Your silica. When you do that, what are you going to have? Na2SiO3 plus your what? Your C plus your carbon dioxide gas that will be involved at the end of the day. Or maybe you just carry your CaCO3, right? And then you heat it with your silica. What is it going to give you? CaSiO3 plus your what? Your CO2 gas. That's all you need there very quickly. Don't forget that if you go and decide to make use of your boron oxide, right? You are using boron oxide instead of your calcium triisocarbonate 4. What will happen? If you make use of your boron oxide B, that's your B2, right? O3. What are you going to have at the end of the day? You, instead of it to have your soft glass, or the one you call your soda glass, what you are going to get is your hard glass. What type of hard glass is that? Hard borosilicate glass will be formed at the end of the day. So, but if you use your calcium triisocarbonate 4, what is it going to give you? Soft glass is what you're going to have at the end of the day. If you get this, that's all very simple, easy, and direct. If you get that very quickly with me, please. Another thing you must know is your colored glass. So there's what we call your colored glasses. What happens? How do you get your colored glass? All you need is add transition metal. So when you take your transition metal oxide, right, and you make use of it, what are you going to have? You're going to have colored glass at the end of the day. A good example is your what? Your cobalt oxide. So when you take your cobalt oxide, first cobalt oxide will give you what? Blue color, right? Beautiful. Another very quickly is your what? Your chromium oxide is going to give you your green color. That's how we call them your colored glasses. Colored glass. You don't want your normal transparent glass, right, that you have. You need colored glass. All you need to do is introduce your transition metal oxide to it. That's all. You know your transition elements, they form colored complexes, right? If you are bringing it in, what are you going to have at the end of the day? Colored glass, so you are going to have. And don't forget this, that glass can be manufactured in flat sheets. Or you may decide to say, okay, no, I want to blow it into a different shape, right? I want to use glass to form test tube, your water bottle, or any kind of bottle or flask, anything, whatever, or even your cooking pot. You can use it. You can use your glass in making all of this. And there are some glasses that can withstand high temperature, right? Especially those your test tube, they are called your Pyrex glass. Very simple. This is all they want us to note here. You get that very quickly with me. Answer this question for us. Now, the question here, all the way, question 2, say bleaching powder. Before we even go first, what is the formula of bleaching powder? The formula of bleaching powder is your CaOCl2.H2O. Don't ever forget it. What is the formula of your bleaching powder? CaOCl2.H2O.H2O.H2O. So your bleaching powder deteriorates on exposure to air because option A. Option A says because it loses its water of crystallization. H2O is going to lose that water of crystallization. Option B says its atmospheric nitrogen is going to displace chlorine away from it. Atmospheric nitrogen. So if your bleaching powder reacts with atmospheric nitrogen, you know your air is a mixture of gases, and air constitutes and your nitrogen that is in air is how many percent? 78% of air is what? Nitrogen. So that nitrogen now, right, they say it's going to displace your chlorine, right, away from your what? Your bleaching powder. Is that true? Option C says your carbon dioxide gas of the atmosphere, right, is going to display what? Your chlorine from your bleaching powder. Now listen carefully. You know your air is a mixture of gases. It contains 78% nitrogen, and again nitrogen is used as what? Diluent. Jamb question. Nitrogen serve as what? Diluent. Another thing is this: 21% of your air is made up of your what? Your oxygen, and then 0.03% is your what? Your carbon dioxide. Now listen. Option C says your carbon dioxide gas, right, is going to display chlorine away from your what? Your bleaching powder. We don't know. Option D says your bleaching agents should be stored in what? In solution. So bleaching powder deteriorates on exposure to air because option D says bleaching agent should be stored in what? In solution. These guys are wrong. What is the correct answer? Before I explain, the simple answer here is option C. Very easy and direct. Now let me explain this to you. Option C says your carbon dioxide, right, of atmosphere has the ability to go and displace chlorine from your what? Your bleaching powder. First, before we move on, again, what's the formula of your bleaching powder? It is your CaO, right? CaO, Cl2 dot what? H2O. Now, come with me. Let me show you something lovely. Take note that your bleaching powder, right, is unstable, especially when it comes in contact with your what? Your air. And because it is unstable, it will react with air. Not all the components of air, no. It will only react with the carbon dioxide. That's your carbon dioxide. When it reacts with it, what is going to happen there? Very simple. It's going to displace chlorine gas away from it at the end of the day. So anytime your bleaching powder reacts with air, which component of air is going to react with the bleaching powder? Your carbon dioxide. So it's going to displace the chlorine away from it. If it displaces chlorine away from it, now very simple, look at it. The reaction is simple. This is your bleaching powder. If it reacts with air, which part of air is going to react with it? Your carbon dioxide. This is another past question over here. Which part of air reacts, atmospheric air reacts with your bleaching powder? Carbon dioxide. If it reacts with it, what is it going to form? It's going to form your calcium triazocarbonate 4, CaCO3, plus your water, right? This water here will be released, and please, this is the most important thing there. Your chlorine gas will be displaced at the end of the day. Does it make sense? Don't forget this, that this means that over time, right, as you expose your bleaching powder, what will happen there is going to lose chlorine. And as it loses the chlorine, what will happen? It will reduce the effectiveness of the what? Of the bleaching powder. Why? Because chlorine is out of it. Again, what does bleaching powder react with? It reacts with your CO2. And what is it going to form? CaCO3 plus H2O plus your what? Your Cl2. And the chlorine gas is what will be what? Giving off at the end of the day. Very simple, easy and direct. Are you sure? Okay. Get this very quickly with me. Look at question 3 here. Hold on a bit very quickly. This class you're watching right now is just one out of a series of classes within the LearnLift app. And guess what? LearnLift is a mobile app, right, where you study intensively as well as extensively. So within the LearnLift app, you can see it very quickly. You have access to all your subjects there. You have your use of English, you have your mathematics, you have your physics, you have your chemistry, you have your biology, you have your Jamb 400. All of them, they are different subjects within the LearnLift app. And of course, you have different topics under every particular subject. And everything has been narrowed down to you, down to the curriculum, with their past questions and everything to the core. And don't forget that within the LearnLift app, you have access to your what? Your video lessons, where you can start going through your classes uninterrupted. You have access to your notes. Oh yes, your notes, well organized, well structured for you, and you are running through all of them. And of course, inside the notes are past questions for you. You have access to your past questions in CBT format, where you can go through all of them extensively well. All of it within the LearnLift app for you and more. And guess what? Very important. You want to download the LearnLift app? All you need to just do is head down to Play Store or your App Store and type LearnLift. That's all. Once you type LearnLift, of course, the app is going to pop up for you, and you're going to see the logo, and then you download the app, and then you follow up on your studies intensively. Before we proceed, let's get back to class. Flow with me. Question 3 says, the force that holds naphthalene crystals together, the forces holding naphthalene crystals together can be overcome when naphthalene is heated to a temperature of your 354 Kelvin, right? Resulting the crystals melting. The forces are known as, which force holds naphthalene crystal together? Option A says Coulombic force. Option B say ionic. Option C say covalent. Option D say Van der Waals. This is constant question. What is the answer? Van der Waals force. Option D is the correct answer. Listen. Now, what's your Van der Waals force before we even move on? Van der Waals force is an intermolecular force. So, a compound, right, can operate, whether compound or molecule, it can have probably ionic bond or maybe, let me say, covalent bond. And at the end of the day, go and have your Van der Waals force in operation within it. Yes, very easy. Now, let me explain this very fast. First, you must understand is that naphthalene first is non-polar molecule, non-polar. So if naphthalene is non-polar, leave weak Van der Waals forces out, right? Let's say something is non-polar. If it is non-polar, will it have covalent bond or ionic bond? Of course, it's going to have your what? Your covalent bond, because your covalent bonds, they operate in your substances that are non-polar. Ionic compounds are polar, right? Beautiful. So covalent, they are majorly what? Non-polar. So your naphthalene is non-polar molecule solid that is composed of what? Covalently bonded molecules. So it can still have your weak Van der Waals forces and then still has covalent bond. Yes. Are you getting it now? So, but what hold the crystal structure are the Van der Waals forces. And those Van der Waals forces, especially, are the London depression forces. And you know that these are the weakest form of your what? Your forces. And don't forget this, that they are weak intermolecular forces that arise due to temporal dipoles that are created by electron movement. Naphthalene or your Van der Waals forces, do they have temporal dipoles or they have permanent dipoles? They don't have permanent dipoles, they have temporal dipoles. I wish they have permanent dipoles, they would have the forces that will be in operation, there will be dipole forces of what? Interaction. I've treated this, all of these things under your what? Your chemical bonding. Another thing very quickly is this. Since these forces are weak, right? What will happen? They can be easily overcome by what? Naphthalene, especially when you heat it, right? And then it's going to what? Melt. The crystals will melt at the end of the day. Because the crystals are melting, right? Which force is holding it? It is your what? Your Van der Waals forces, especially your London depression what? Forces. You get this very quickly with me. What are other substances, right, that have these weak Van der Waals forces in operation in them? Very simple. You must know them. Noble gases, weak one Van der Waals forces. Don't stress yourself. That whether it is your helium, your neon, your argon, weak Van der Waals forces is all you have there, right? So they rely solely on your weak Van der Waals forces or your London depression what? Forces. Another one very quickly are the non-polar molecular solids. Non-polar, not polar. A good example like your methane. We have others like your oxygen. We have others like your nitrogen. You see these guys like this, right? Weak forces. We have others like your carbon dioxide. We have things like your benzene. We have things like your what? Your naphthalene, right? All these guys are weak forces. That's why you see when they just ask you your carbon dioxide, your naphthalene, you know exactly where they are going to under your intermolecular forces. They are not asking you whether it is covalently bonded or your what? Electrovalent bond. That's not what they're asking you. They're asking you for the what? Intermolecular forces there. Another area you can see them are your halogens, right? Halogens, especially diatomic molecules. Halogens are all diatomic, whether it is your fluorine or it is your chlorine or it is your bromine or it is your what? Iodine. But please, iodine, right? They have relatively high, or they are the ones that show more of your what? Your weak Van der Waals forces. Why is it so? It's so because as you are coming down, right? As you are coming down in the periodic table, what happened? The weakness, right, is going to be increasing. So the more you are coming down in the periodic table, the weaker they become. So which of them will have the highest Van der Waals force in operation in them? Of course, it is iodine. So when you hear iodine, naphthalene, these are the things that they ask in Jamb very well. Iodine, naphthalene, CO2, this guy, right, in terms of their intermolecular forces, Van der Waals. Another thing very quickly are your hydrocarbons, right? Which of the hydrocarbons, alkanes, which of them? You see them in your ethane, you see them in things like your propane, you see them in things like your butane. You also see them in your what? Your pentane, right? As well as other alkanes. You also have your what? Your weak Van der Waals forces in operation, but they are covalently bonded molecule. Beautiful. Together very quickly with me. Another thing that they brought in the option was the aspect of your Coulombic force. Right? Because some people, instead of them to choose your Van der Waals forces, they will rush and go and choose Coulombic force. What is Coulombic force? Note this very quickly, that your Coulombic force is an electrostatic force that occurs between charged particles. Whether it is your positive and negative charge, Coulombic force is in operation there. So, like your sodium chloride now, right? You know your sodium chloride, it has ionic bond, right? Of course, it has ionic bond. You can say it has Coulombic force in operation between the sodium and the chlorine ion. Another very quickly is your ionic forces. You know your ionic bonds already, right? They occur, or these forces, you see them in your ionic compounds, where one is positive, the other is negative, and there is complete transfer of electron from the positive to the negative, right? Beautiful. And don't forget, a good example is your calcium chloride, right? They are held together by your ionic forces. And then I've explained to you before that one sweet thing about your ionic compound. How do you know that a compound is ionic? Very simple. Ionic compound is formed. This is just the secret for Jamb. Your group 1, your group 2, group 3. If they react with your group 5, your group 6, your group 7 elements, which bond is there? Ionic bond. Simple. Your group 4, right? Your group 4 elements as a covalent bond. So anything that make your group 5, group 6, group 7, probably group 5 is reacting with your group 6, or your group 5 is reacting with group 7, or group 6 is reacting with group 7, which force or which bond is in operation there? It is your covalent bond that will be in operation there. Very simple, easy, and direct. You get that very fast. Also, what about your covalent forces here? Don't forget that covalent bond occur within molecules that share electrons. They are sharing. So in your ionic bond, there is complete transfer of electron, but in your covalent bond, there is sharing of electrons. A good example like your pure diamond, right? Your diamond, right, which is an allotrope of your carbon. It has strong covalent bond holding the molecules together. If you get that very quickly with me, that means you are doing well now. Show you the wine me. Look at this question, Joe. The question here, all the way, it says the product of the thermal decomposition of ammonium trioxonitrate 5. There are certain things you don't think. If you decompose ammonium trioxonitrate 5, what is it going to give you? Is it going to give you NO2 and oxygen, or ammonia and oxygen, or your nitrogen and water, or it's going to give you N2O and water? Listen, very simple. These are constant. There are certain things that are basic that you must know. The product of thermal decomposition of ammonium trioxonitrate 5 will give you N2O and water, option D, right? You know they have been shouting this right from when you were in SS1 now. If you decompose ammonium trioxonitrate 5, what will it give you? It will give you N2O and water. Very easy. Why is it so? Now listen carefully. Once you carry your ammonium trioxonitrate 5, this is the formula: ammonium NH4, trioxonitrate 5 NO3, NH4 NO3. What is it going to happen? As you decompose this, thermal decomposition, applying heat to it, what will it give you? N2O, N2O, not NO2, never. What will it give you? N2O and what? Water. What's N2O? N2O is your laughing gas. That's why they are even asking it in the first instance. N2O is what? Laughing gas. And don't forget that this reaction will produce your dinitrogen monoxide. When you hear dinitrogen monoxide or dinitrogen 2 oxide, what's that? Laughing gas. So it is also known as your nitrous oxide, or your laughing gas. Are you getting it now? So your laughing gas and water will be formed anytime you decompose, right, your ammonium trioxonitrate 5 thermally. That's all. Okay, please understand this. There are different oxides of nitrogen that you must pay attention to. What are the various oxides of nitrogen? I'll give you 6 of them that they don't play with. Number 1 oxide of nitrogen is called your dinitrogen 1 oxide. It's not come. You know, a lot of people will say N2O and they will call it dinitrogen 2 oxide. No. It is dinitrogen 1 oxide, right? Dinitrogen 1 oxide. Let's not go into oxidation state because I have a lot of questions on oxidation states ahead as we are moving. So your dinitrogen 1 oxide is your N2O. First, before you know it as laughing gas, what is the name? N2O is your dinitrogen 1 oxide. Does it make sense? And don't forget this, that it is a colorless gas. What is it? Colorless gas with slightly sweet odor. So it has sweet odor. As you just inhale it, what happens to you? You start to laugh uncontrollably. That's why they call it laughing gas. And don't forget this quickly, that it is used as anesthetics in dentistry and surgery, especially dental surgeons or surgeons generally, right? They make use of it as anesthetics. And don't forget this, that it is also used as greenhouse gas. Are you getting it now? Greenhouse gas. your what? Your laughing gas. If you get that very quickly with me. Another thing you must know is for your nitric oxide. What's your nitric oxide? Nitrogen 2 oxide. The one that is nitrogen 2 oxide is NO. Yes. NO is what? Nitrogen 2 oxide. What is the oxidation state of your nitrogen there? It is what? +2. Because oxygen is -2 here. Nitrogen there is what? +2. So your nitric oxide or your nitrogen 2 oxide is what? NO. But your N2O is your what? Your dinitrogen what? 1 oxide. Now, what should I know about your nitrogen 2 oxide? Number one, it is a colorless gas that reacts with oxygen to form your what? Your nitrogen dioxide. Another thing very quickly is this. It is involved in biological signaling in the body. Another thing very quickly is used in the production of your what? Your nitric acid. Number three is your nitrogen dioxide. Now, your NO2 now is your what? Your nitrogen dioxide. So your again, come with me. Your N2O. What is N2O? It is dinitrogen what? 1 oxide. Right? Beautiful. Let's dwell on your nitrogen dioxide. It is brown gas. That's number one first before we even move. Brown gas. So whether brown gas or reddish brown gas, you are correct. And it has pungent odor. Pungent what? Odor. Are you getting it now? And don't forget this, that it is a major air pollutant from your what? Your combustion engine and in your industrial processes. And another thing very quickly is that it reacts with water. When it reacts with water, what will it form? It will form nitric acid, right? And that is what contributes to what? Acid rain. Which one contribute to acid rain? Is it your NO2 or your N2O or your NO? Which one will contribute to acid rain? The one that contribute to acid rain is your what? Your NO2. NO2, your nitrogen dioxide, will contribute to what? Your acid rain. Which one is your laughing gas? N2O is your laughing gas. It is also used as what? Anesthesia. Another one very quickly is your what? Your dinitrogen 3 oxide. What is your dinitrogen 3 oxide? It is your N2O3. It is pale blue gas. Are you getting it now? And don't forget this, that of course it is a blue gas at what? Low temperature. And very important, it exists in equilibrium with NO and NO2. They don't really ask that. And please, very important, this is what you should know. It decomposes to form nitric acid in the presence of what? Water. Number 5 is the one we call your what? Your dinitrogen 4 oxide. What's your dinitrogen 4 oxide? It is a yellow gas. N2O4 is a yellow gas at room temperature. Number one thing is that it exists in equilibrium with what? NO2. And very importantly, it is used as what? Rocket propellant oxidizer. Right? So they use it like as rocket fuel. And very importantly is that it is highly toxic and what? Corrosive. Then number 6, which is the last but not the least, is your dinitrogen 5 oxide, which is your N2O5. It is what? An hydride of nitric acid. What do they use it for? Number 1, it is a white solid. What is the color? It is white, right? And don't forget this, that it is highly reactive and used in the production of what? Explosives, like those your bombs and the rest of it. Very important is that it dissolves in water to form your what? Your nitric what? Acid. And you know your nitric acid is HNO3 already, right? Beautiful. If you get it very quickly with me, no stress. Let's fire down. This class you just finished watching, of course, is brought to you by what? By the LearnLift app. Oh yes. And within the LearnLift app, you have access to all your classes from the beginning to the end. Everything is well organized for you. Every singular subject, every singular topic followed in line directly with your syllabus and your curriculum. And of course, can I tell you something lovely about the LearnLift app? Oh, this is the sweet part of it. You have access to your Jamb classes within the LearnLift app. You have access to your WAEC, your NECO, your GC classes. You have access to your post-UTME classes. And that's not all. Of course, for your secondary school, you have access to your secondary school classes, whether SS1, SS2, SS3. You have access to your classes directly. And of course, if you're in the university, you have access to your 100 level as well as 200 level classes, all within the LearnLift app. And of course, your 200 level classes are for medical students. All of them are there, well structured and highly organized for you. But please, before you proceed, just head down to your Play Store or your App Store and just type what? LearnLift. Immediately you type LearnLift, of course, the app is going to pop up for you and you download the app and then you start learning immediately. And also very quickly, all you're going to do is that in the description of this video or in the comment section, just open it. You see the link to our WhatsApp channel. Click on it and you are in the WhatsApp channel already, where I'm going to be dropping information every blessed day on a regular basis. And also very important, if you want to reach out to LearnLift, this is LearnLift contact, any of the two, right? Just copy it down and then WhatsApp us, right? Either you send WhatsApp message or you put a call across to us and all of that, and we're going to attend to you immediately. Guess what? I'll see you in the next chapter. For the now, peace out. Bye.